Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in. The promise of the software-defined vehicle appears to be constantly just over the horizon, with every new generation of cars touting more advanced driver assistance, more connectivity, more AI. But according to a recent analysis, a lot of automakers are walking right into what's being called the Semi-SDV trap.
That's right. The core argument is that while many car manufacturers are heavily investing in high-performance computing, specifically AI chips and powerful electronic control units, they're neglecting a crucial foundational layer. They're focusing on the brains, but not the nervous system.
So it's not just about raw computational power. This suggests they are building supercomputers on wheels, but without the fundamental software infrastructure to make it all work cohesively?
Precisely. The report suggests that without this critical missing piece, these advanced vehicles will struggle to deliver on the full promise of software-driven innovation, remaining in a kind of technological limbo.
Regarding this semi-SDV trap, what does it actually mean for a car to be software-defined in the first place, and where are car makers falling short?
Conceptually, a fully software-defined vehicle, or SDV, is one where the majority of its features and functionalities are implemented, controlled, and updated through software, rather than being hardwired or solely dependent on specific hardware modules. Think of a smartphone. Its capabilities are defined by its apps and operating system, not just the processor. The expectation for an SDV is similar: new features, performance enhancements, and even entire business models delivered via software updates.
And the trap part? Where does the current approach diverge from that ideal?
The trap, as identified in the report, is the industry's disproportionate focus on the raw hardware, those powerful AI chips, sophisticated sensors, and an ever-increasing number of ECUs, or electronic control units. These are undoubtedly important for tasks like advanced driver assistance systems, or ADAS, and future autonomous driving capabilities. However, without the right software layer to manage and orchestrate all these disparate hardware components, the system becomes fragmented. It's like having a dozen specialized supercomputers all running independently in the same box, each requiring its own unique way of being programmed and updated.
So instead of a unified platform, they're creating a collection of high-tech silos.
Exactly. And this leads to significant challenges. Development becomes incredibly complex and expensive. New features are slow to roll out, and the ability to perform seamless over-the-air, or OTA, across the entire vehicle is severely hampered. They end up with impressive hardware capabilities that are difficult to fully leverage or evolve.
And the missing piece alluded to earlier, the nervous system, if you will, is middleware. What exactly does that mean in the context of a car? Because for most people, middleware might sound like something from enterprise IT, not something that goes into a vehicle.
That's a good distinction. In the automotive context, middleware refers to the software layer that sits between the vehicle's operating system, or OS, and the hardware on one side, and the application software, the features that end users interact with, on the other. Its primary role is to abstract away the complexity and heterogeneity of the underlying hardware and OS, providing a standardized set of services and interfaces for application developers.
So it's not the operating system itself, like Linux or QNX, but it works with the operating system.
That's correct. The operating system handles fundamental tasks like process management and memory allocation. Middleware then builds on that by providing higher-level services. Imagine an application that needs to access sensor data, control an actuator, or communicate with another part of the car's system. Without middleware, that application would have to be written specifically for the unique hardware and OS configuration of that particular ECU. With middleware, it makes a request to a standardized service, and the middleware handles the translation and communication with the specific hardware.
What kind of standardized services are we talking about?
The report highlights several key functions. These include inter-process communication, allowing different software modules to talk to each other reliably; data management, handling the vast streams of sensor data and vehicle state information; resource management, allocating compute power and memory efficiently; security features, ensuring safe and authorized interactions; and diagnostics. Essentially, it provides the common utilities and infrastructure that all vehicle applications need, preventing each developer from having to re-implement these fundamental capabilities from scratch.
This suggests a lot of work is currently being duplicated then.
It is. The current architecture in many vehicles is often a patchwork of dozens, sometimes over 100 individual electronic control units, or ECUs, each with its own embedded software, often supplied by different Tier 1 vendors. Each ECU might have a distinct microcontroller, operating system, and communication protocols. This fragmentation creates immense complexity.
So if a car maker wants to add a new feature, say a new advanced parking assist system, what's the current pain point this middleware would solve?
Without robust middleware, that new parking assist system would likely need to be developed specifically for the particular ECUs and software stacks involved. It might require integrating with proprietary communication protocols, understanding specific hardware quirks, and navigating a labyrinth of existing, often legacy software. Each update or modification becomes a bespoke engineering effort. The cost and time implications are substantial. The report underscores that this fragmented approach leads to vendor lock-in, where automakers become heavily dependent on their Tier 1 suppliers, not just for hardware, but for the deeply integrated software that makes it run. This stifles innovation and agility.
So automakers lose control over their own software destiny, essentially.
Exactly. They become integrators of black box components rather than owners of their software stack. This impacts their ability to differentiate, to quickly deploy new features, or even to monetize new services. The report suggests that this current model limits their ability to shift towards the service-oriented architectures that are envisioned for true SDVs, where features can be dynamically added or updated.
The report draws a strong parallel to the evolution of IT and cloud computing, describing how automotive software needs to become cloud-native in its approach. Can you elaborate on that analogy?
The analogy is quite powerful. In the early days of IT, applications were often monolithic, tightly coupled to specific hardware servers. Deploying new software was a lengthy process, often involving manual configuration and hardware provisioning. Cloud computing revolutionized this by introducing standardized platforms, virtualized infrastructure, and middleware services. Developers could deploy applications without worrying about the underlying physical servers. They interacted with APIs and services.
And the vehicle today is essentially that early monolithic IT system.
In many ways, yes. Each ECU is like a dedicated server with its own custom operating environment. The shift to a cloud-native approach in automotive means moving away from these tightly coupled, monolithic functions. Instead, vehicle features are broken down into smaller, independent, and reusable software services. These services run on a common middleware platform that abstracts away the hardware differences, much like a cloud platform abstracts server infrastructure.
So a braking function might not be one giant block of code tied to a specific ECU, but rather a set of services that can be called upon by other applications.
Precisely. Imagine a braking service that an ADAS system could invoke or that a new stability control algorithm could leverage. This service-oriented architecture, or SOA, is enabled by middleware. It allows for much faster iteration, easier testing, and significantly better reusability of software components. It's the foundation for building an ecosystem where different teams or even third-party developers can contribute features that reliably interact with the core vehicle systems.
This appears to be a dramatic restructuring of how cars are designed and built from a software perspective. This brings up the question of who builds and owns this middleware layer. Historically, car makers relied heavily on their Tier 1 suppliers for integrated hardware and software solutions. Does this change that dynamic?
Fundamentally, yes. The report emphasizes that for automakers to truly realize the potential of the SDV, they need to own this middleware layer. If they continue to rely on proprietary, vendor-specific middleware solutions from each of their Tier 1 suppliers, they simply perpetuate the fragmentation problem. They need to define, or at least heavily influence, the core middleware platform that underpins their entire vehicle architecture.
So it's a strategic imperative for OEMs to regain control of their software stack. What are the options here? Build it entirely in-house? Collaborate? Acquire?
All three are being explored.
Building it entirely in-house is a massive undertaking, requiring significant investment in software engineering talent, which is already a competitive landscape. Collaboration, perhaps through industry consortia or joint ventures, is another route, aiming to create a common standard. And acquisition of software companies or specialized middleware providers is also on the table. The key takeaway is that the traditional relationship with Tier 1 suppliers, where they deliver full, integrated black box systems, is evolving. Tier 1s will still provide hardware and specialized software, but they'll need to integrate into the OEM's defined middleware platform.
This shift isn't just a technical challenge then, it's a huge organizational and business model challenge for the entire automotive supply chain.
Absolutely. It changes who holds the intellectual property, who defines the interfaces, and ultimately, who controls the customer experience and future revenue streams. The incentive for automakers to do this isn't purely technical efficiency. It's about enabling new subscription services, personalized features, and faster innovation cycles that can open up entirely new revenue opportunities over the vehicle's lifespan. If they don't own the software platform, they can't fully capitalize on those opportunities.
So what are the primary hurdles to implementing this critical middleware layer? The benefits might suggest it's a straightforward solution, but it clearly isn't an easy transition.
You're right, it's far from easy. The challenges are multifaceted. Firstly, there's the sheer technical complexity of integrating new middleware with existing legacy vehicle architectures. Cars aren't designed from a blank slate every year. There's a huge installed base and established engineering processes that need to be considered. Rewiring a vehicle's software backbone is an enormous undertaking.
And safety must be paramount in that context.
It is. Secondly, and critically, there are the stringent automotive safety standards, like ISO 26262. Any new software layer, especially one that sits so close to core vehicle functions, needs to undergo rigorous validation and certification. That adds immense time and cost. The fail-fast mentality common in consumer software development doesn't translate directly to automotive. Thirdly, there's the talent gap. Automakers need a significant influx of highly skilled software engineers who understand both large-scale distributed systems and the unique constraints of automotive environments. This expertise is in high demand across many industries.
It's a fundamental cultural shift too, isn't it? Moving from being primarily hardware manufacturers and integrators to becoming software product companies.
Exactly. It requires a change in organizational structure, development methodologies, and even corporate culture. The report implicitly highlights that this isn't just about writing lines of code. It's about rethinking the entire value chain and how a vehicle is conceived, developed, and maintained throughout its lifecycle. The commercial imperative, as mentioned, is the driver here. New revenue models from subscription services, personalized features, and improved operational efficiency. The long-term vision is a vehicle that truly evolves and improves over time, much like a smartphone or a cloud service.
What are the key takeaways from this discussion about the Semi-SDV trap and the role of middleware?
First, the Semi-SDV trap is the risk of having advanced hardware without the software infrastructure to fully utilize it, leading to fragmentation and inefficiency. Second, middleware is the crucial abstraction layer that decouples application software from hardware, enabling standardized services and communication across the vehicle. Third, adopting this middleware is essential for automakers to regain control of their software stack, reduce development costs, and accelerate feature deployment. It allows them to transition to a service-oriented architecture, much like the cloud-native shift in IT.
And finally, this isn't just a technical upgrade, it's a profound strategic shift that impacts the entire automotive industry, forcing OEMs to become software owners and reconfiguring their relationships with traditional suppliers.
Indeed, it's about enabling the long-term vision of truly software-defined vehicles that can adapt, evolve, and offer new services throughout their operational life.
So the critical questions for automakers now are, can they successfully navigate this complex transition to owning their software platform, and what will be the ultimate impact on the consumer experience and the very definition of vehicle ownership itself?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.